Today I'm going to start with problem 28 from lesson 72. This problem is a square root problem, and it says simplify, and we have 3 times the square root of 18 minus 7 times the square root of 8 plus 3 times the square root of 50 plus the square root of 32. So what we have to do is we have to break down what's inside these radicals here. So 18, we could do 9, the square root of 9 times the square root of 2. The square root of 9 is 3, so we can go ahead and take that out and multiply it by this 3 over here. So when you break something out of the square root, a factor comes out of there, you multiply it by what is on the outside of the radical. So 3 times 3 is 9. And then we're left with square root of 2. We couldn't break that down anymore, so we have to leave that. 8, we could do that as 4, the square root of 4 times the square root of 2. The square root of 4 is 2, so we can pull that out and multiply it times 7. 2 times 7 is negative 14, and we still have square root of 2. We couldn't break that down. 50, that could be 2 times 25. And the square root of 25 is 5. So we're going to multiply that times this 3. 3 times 5 is 15. And we're left with square root of 2. And then 32, the easiest way to do that one would be square root of 2 times the square root of 16. And the square root of 16, 2 times 16 is 32. Square root of 16 is 4. Now we don't have anything to multiply it by over here, so we're just going to write plus 4. And we still have square root of 2. 4 times the square root of 2. Now you'll notice that all of these are square root of 2, so we can call them like terms. They're all like terms. So now all we have to do is add them. I like to find all my positives and add them up first. So 9 plus 15 plus 4, which is going to be 28 times the square root of 2 minus 14, our only negative, times the square root of 2. And that is going to be 28 minus 14 is 14 times the square root of 2. So that is the answer to number 28 on problem set 71. Okay, this is lesson 73. Factoring the difference of two squares and probability without replacement. First, we're going to do factoring the difference of two squares. So what is a square? A square number is something where you multiplied it by itself and you come up with that number. Like if we said 2 times 2 is 4, 4 is a square number. X times x is x squared. X squared is a square number because you can break it down into two components, two factors that are the same. All right, so when we multiply two binomials and come up with a trinomial, sometimes if we multiply them, we will end up with a square. So the two binomials that are both squares, x squared minus y squared, or that's x squared is a square number and y squared is a square number, and 4p squared minus 25, 4 is a square number, p squared is a square number, 25 is a square number. These are called the difference of two squares, and I'm going to show you why that is. So if we take x plus 2 and we multiply it times x minus 2, so it's the difference. So one has a plus sign and one has a minus sign. Other than that, they're exactly the same. Let's multiply this out, and we're going to come up with what's called the difference of two squares. So x times x is x squared. X times negative 2 would be negative 2x. 2 times x would be positive 2x. And 2 times 2 is 4. Now, we'll always end up with like terms in the center, and when we put those together, minus 2 and plus 2, we get 0. So we're left with x squared. Whoops, this will be minus 4. Minus 4. And this is a square number, that's a square number, we don't have anything in between. That is called what's called the difference of two squares. So now I'll do another one just to show you. So let's say that we had x plus 3 times x minus 3. All right, so we've got x times x, x squared. And then we've got x times negative 3, negative 3x. X times positive 3, positive 3x. And then 3 times negative 3 would be negative 9. Then we can see that these two are opposites of each other. They basically cancel each other. Minus 3 plus 3 would be 0. And we get x squared minus 9. Now we know that this is the difference of two squares problem because that's a square number and that's a square number. Alright, so they're going to ask you to factor the difference of two squares. An example would be negative 4, let's not do that one. They wrote that one backwards. Let's say m squared minus 49. Well, we can see that this is a square number and that's a square number. So all we have to do is write our parentheses. And m will go in for both of these because m times m is m squared. And then what is the square root of 49? It's 7. So 7 goes in both of these. And then we need a plus and a minus. So you just find the square root of this number and put it at the end, square root of the first one, and put it at the beginnings. And then you have a positive and a negative. Now if we FOILed this out, or we rainbowed it, m times m squared, m times negative 7, negative 7m, 7, positive 7 times m, positive 7m, and then 7 times negative 7 would be negative 49. These two cancel each other, and we're left with m squared minus 49, what we had at the beginning. You don't even have to do all that work. All you have to do is find the square root of the first number and the square root of the second number. All right, let's try one a little bit harder. This one is 9x squared minus 49. Okay, so we're going to draw our parentheses. And then we're going to have, one's going to be a plus and one's going to be a minus. What is the square root of 9? That would be 3. So we got 3 on the beginning on both of those. And then what's the square root of x squared would be x. So both of these will have an x in the beginning, in the first part. Now this second part right here is going to go on the other side of the plus or minus sign. And the square root of 49 is 7. And that's how you solve that kind of problem, the difference of two squares. Now, if you wanted to FOIL this back out, you could. You could say 3 times 3 is 9, x times x is x squared. And then you could go over here, 3 times 7 is negative 21x. Then you go right there, 3 times 7 is 21, so that'd be positive 21x. And then right here, 7 times 7 is 49. These two, oops, that should be 21x. These two cancel each other, and you get 9x squared minus 49. Back to what we had at the beginning. So if you do one of those and you're not sure if your answer is right, just multiply it back out, rainbow it back out until you come up with what you had at the beginning. All right, this one's negative 4 plus x squared. Now this one's a little harder for us to see because they've got it in the wrong order there. So I'm going to swap them. We always want descending order of variables. That means our highest variable, our highest exponent goes first. So x squared minus 4. Now we can see what's going on. That looks a little bit better. So I'm going to draw both my parentheses. And I know I'm going to have a plus and a minus. And the square root of x squared would be x. So put an x because x times x makes x squared. And then the square root of 4 is 2. So put a 2 in both of those because 2 times 2 is 4. They're actually pretty simple. They're easier than the other kind. We'll do another one. Factor 49 m squared minus a squared. All right, so we draw our parentheses. And what's the square root of 49? Would be 7. And what's the square root of m squared? Would be m. And we're going to have a plus and a minus. And then the square root of a squared would be a. So it's going to be the same thing, except for one's a plus and the other one's a minus. And it doesn't matter what order you put them in. You can put your minus over here and your plus over here. and it would still be the correct answer. All right. Two more examples here. So this one says factor negative 36a squared plus 25y squared. All right, so the first thing we're going to do is recognize that both terms are perfect squares. We've got to begin by reversing the order because we want our minus sign to be in between our two monomials there. So I'm going to rewrite this as 25y squared minus 36a squared. Now I'm going to draw my parentheses. This first one, square root of 25 is 5. I'm going to put that in both. Square root of y squared is y. Put that in both. Now I'm going to have a plus sign and a minus sign. Square root of 36 is 6. Put that in both. And the square root of a squared is a. So we should have 5y plus 6a times 5y minus 6a. And if you rainbowed all that out, you will come back up with that answer. Because we know 5 times 5 is 25. Y times y would be y squared. 6 times 6 is 36. And a times a is a squared. Okay, next one says factor negative 36 x to the 6th y to the 4th plus 49a squared. All right, we can recognize that both of these terms are perfect squares. We begin by rearranging. So we're going to rearrange those, and we're going to go with 49a squared because we want this minus sign. We want this term to be at the end because it's the negative term. 36x to the 6th, y to the 4th. Okay, so first part's pretty easy. We're going to draw our parentheses. Now we're going to concentrate on that 4. We know that 2 times 2 makes 4. Now we're going to focus on that a squared. That will be a times a. And we know we have to have a plus and a minus. The next one is this 3. Oh, it's not 3x to the 6th. It's 36. 36x to the 6th. There we go. All right, so the 36, that would be 6 times 6. X to the 6th. Well, if we have x to the 6th, that would be half of that. If we did the square root of x to the 6th, it would be x to the 3rd. You just cut it in half. Y to the 4th, we're just going to cut that in half. It would be y squared. Because y squared times y squared would be y to the 4th. X to the 3rd times x to the 3rd would be x to the 6th. When we multiply exponents, we add them. Alright, so basically you're just dividing it by 2. You're dividing it in half. So you should have, oh, I put 4 here. That should say 49. And that means that these 2's should be 7's. There we go. 7 times 7 is 49. A times a is a squared. 6 times 6 is 36. X to the 3rd times x to the 3rd is x to the 6th. Y squared times y squared is y to the 4th. All right. Okay, the next part of the lesson is probability without replacement. So, when we make successive random selections of marbles from an urn, the probability of a certain outcome on the second draw is affected by whether or not the marble we selected on the first draw is returned before the second draw is made. Okay, so let's say that we have a jar and it's got some marbles in there. An urn contains 3 black marbles. Okay, 3 black marbles. And 5 white marbles. Okay, there's our jar. 3 black ones, 5 white ones. Our marble is drawn at random and replaced. And then a second marble is randomly drawn. What is the probability that Both marbles are black. So, first of all, it doesn't say that we replaced that. Let's see. No, it does say that we replaced it. So we drew one marble, and the probability of getting a black marble will be 1, 2, 3. There's 3 black ones. There are 5 white ones. And then the total would be 8. We have 8 total marbles. 1, 2, 3, 4, 5, 6, 7, 8. So the probability of drawing a black one would be 3 out of 8. And then the probability, if we replace the marble, of drawing a black one, you just multiply your probability. So the second time would be 3 out of 8. So for us to get it both times, we have to multiply that. So it would be 6 out of 8 times 8 is 64. Which would reduce to, 3 times 3 is 9. 9 out of 64. Which does not reduce. Alright, so that was part A of the question. Then part B says, if the first marble is not replaced before the second marble is drawn, what is the probability that both marbles are black? Alright, so the first one, the probability stays the same. It's 3 out of 8. That's our first marble. Alright, now let's say that we pulled a black marble that first time, and it's not in the jar anymore. We took it out and we did not replace it. Now what is the probability of pulling a black marble? Well, now we only have 2 black marbles, and our total is 1, 2, 3, 4, 5, 6, 7. 2 out of 7. So the probability of getting a black marble the second time is 2 out of 7. So this is our first time, and this is our second time. Now, what is the probability of this happening, both of these happening? So we would have to multiply these together. So 3 out of 8 times 2 of 7. And we can reduce here and get 4, and that would be 1. And 3 times 1 is 3. 7 times 4 is 28. Would be 3 out of 28. So, if we don't replace the marble, it's going to change our ratio of marbles in that jar, changing the probability. Let's try another one. An urn contains 4 red marbles and 7 blue marbles. Now, I always like to do 4 red, 7 blue, just so I can keep up with what's going on. 2 marbles are drawn at random. What is the probability that the first is red and the second is blue if the marbles are drawn, A, with replacement and B, without replacement? Okay, so for A with replacement, that means we don't have to recalculate any of this. So our total would be 11. 11 total marbles. And it's saying, what is the probability that the first is red and the second is blue? So the probability of one being red would be 4 out of 11. And then if we put that one back in, then it would be 7 out of 11 for the second one being blue. Now we multiply these two probabilities together. 7 times 4 is 28. And then 11 times 11 is 121. Alright, B says with replacement, or without replacement. That means we take out the red marble first, and then we don't put it back into the jar. So, when we take it out the first time, we get 4 out of 11. So if we didn't put it back into the jar, then we're going to end up with 3 red marbles in the jar, and a total of 10. Now, what is the probability of us getting a blue marble? Well, it would be 7 out of 10. Now we're going to multiply our two probabilities. 7 times 4 is 28. 11 times 10 would be 110. And we can reduce that. Aha! I'm going to reduce before I multiply. And cancel right here. So that would be 5. And that would be 2. 2 times 7 is 14. And then 11 times 5 is 55. So our probability would be 14 out of 55. So when it says replace with replacement, you just figure out both your probabilities and you multiply to get your answer. Without replacement, then you have to figure out what your new probability is after you pull that first marble. Alright, I think we've got one more I can do. The probability of a blue marble, nope, that was it on that. All right, try to do the practice problems when you're done with those. So pause the video, do the practice problems, and when you're done with those, push play, and I will be doing them on the screen for you. Okay, I'm going to do the practice problems for you. Hopefully you guys did them, and pause the video, and now we're going to see if you got them right. So first one is A, which is 64x squared minus 81y squared. All right, so we can see that these are all square numbers here. So we're just going to draw our parentheses. And first we're going to figure out the square root of 64, which is 8. We're going to put it on both of these. The square root of x squared, which is x. Now we need a plus sign and a minus sign. Now the square root of 81, which is 9. 9 times 9 is 81. And then the square root of y squared would just be y. So that should be 73. Practice for 73. 8x plus 9y times 8x minus 9y. Or you could have it the other way around. You could do plus and minus like that. Okay, I'm going to do B. Alright, B is negative 25 plus 100 m squared. Alright, this one is organized in the wrong way. They're trying to trick us. So we want our negative sign to be our second our second term there. So we're going to swap those around. 100 m squared minus 25. Alright, now we can factor. So we're going to put in our parentheses. The square root of 100 is 10. So we're going to put 10 on both of those. The square root of m squared is m. Now we need a plus and a minus. And the square root of 25 is 5. 5 times 5 is 25. Alright, there was B. Okay, C. C is y to the 4th x squared minus 169z to the 10th. Alright, that's in the right order, so we're just going to look at each one at a time. So first we're going to do this first term, so y to the 4th. Now remember, when we're finding the square root of a higher power variable, all we have to do is cut that power in half. So if this is 4, we're going to cut it in half, we're going to get 2. So y squared. X squared would just be x. Now we come to the minus sign, so we need a plus and a minus. Because to get a negative number right here, we have to have a positive and a negative. That's why we got a plus and a minus. Alright, square root of 169. I think that's 13. Let me check with my calculator. Yes. So 13 in both of these. And then z to the 10th, remember, all we got to do is take that exponent there and cut it in half. So that would be z to the 5th and z to the 5th. Let me double check and make sure I got that right. That was C. We should have y squared x minus 13 z to the 5th times y squared x plus 13 z to the 5th. So like I said before, we could swap these if we wanted to. We could have plus over here and minus there. Either way, as long as your numbers are the same. Alright. Okay, now I'm going to do D. Alright, D says, an urn contains 4 purple marbles and 3 pink marbles. So first thing I'm going to do is I'm going to write purple, 4, pink, 3. I can't write P because they both start with a P, which is sad. 2 marbles are drawn at random. What is the probability of both marbles are purple if the marbles are drawn 1 with replacement and 2 without replacement? Alright, so first we're going to do part 1 with replacement. So first we're going to figure out what the probability of, let's see, what was it? Purple marbles being drawn twice. So we have 4 purple marbles, and the total in the jar is going to be 7. That will be 4 out of 7. And then multiply that times the probability of the second one, which is 4 out of 7. And we're going to get 4 times 4 is 16. 7 times 7 is 49. So it should be 16 out of 49. All right, part 2 is we get the same 2 purple marbles, but without replacement. So when we take 1 purple marble out, that first one is going to still be 4 out of 7. Then we change the jar. So when we take that first purple marble out, then we're only going to have 3 purple marbles, and it will be 3 out of 6. So we're going to multiply that times 3 out of 6, which we can reduce to 1/2. So 1 times 4 is 4, and 2 times 7 is 14. And we can reduce that to 2 out of 7. So part 2 is 2 out of 7. All right, and we got one more of these, E. Smeared that all over the place. Let me fix that. Okay. E. All right, and it says, an urn contains 5 orange marbles and 6 blue marbles. 5 are orange and 6 are blue. Okay. 2 marbles are drawn at random. What is the probability that the first marble is orange and the second marble is blue? So 1 is going to be orange and 2 is going to be blue. And then 1 is with replacement. And then the second part is without replacement. Okay, so with replacement. First we got to get an orange marble, then we got to get a blue marble. So what is the total number of marbles in the jar? That would be 11. Okay, so we've got 11 marbles in the jar, and the first one's orange. That will be 5 out of 11. Now, if we put that marble back in, none of these numbers would change. And to get a blue marble the second time, that would be 6 out of 11. 6 of the 11 marbles are blue. Now we just multiply. 5 times 6 is 30. 11 times 11 is 121. So 30 out of 121. Now we're going to do it without replacement. All right, so the first one being orange is going to be the same, 5 out of 11. Now we took one of those marbles away, so we're only going to have 4 orange marbles left in the jar, and our total number of marbles will only be 10. Now to get a blue marble, that would be 6 out of 10, which would reduce to 3 out of 5. Now we're going to multiply those two together, and we can cancel right there. And we get 3 out of 11. 3 out of 11 is the second part there. All right, so if you have any questions about that, just send me a message. And if you find that confusing, just send me a message, and I'll help you. All right, lesson 74. Lesson 74 is something that you guys have probably done before. It is scientific notation. When we look at numbers written in scientific notation is where we take a big, giant, long number and we turn it into a smaller number that is easy to see. So let's say that we had 362 and then a whole bunch of zeros after it. All right. So we don't want to have to write all those zeros, so we're going to count all the way back and put our decimal. We always want to have one whole number and then a decimal. So I'm going to write that 3.62 times 10 to the, let's see, how many places do we move that decimal? 1, 2, 3, 4, 5, 6, 7 places times 10 to the 7th. So if we multiplied out 10 to the 7th, we would be multiplying 3.62 times, and then we would add 7 zeros. 1, 2, 3, 4, 5, 6, 7. And if we multiplied this, 3.62 times that, we would just move that decimal point back out and we would end up with that number. So So in scientific notation, we would like to place the decimal point between the very first number and whatever number's after it. So we always want to have one whole number and then our decimal numbers after that. All right. Now we can remember that we can also do it the other way. So if we had 0.0000, see how many zeros I got? 1, 2, 3, 4. 416. Okay, so we want to write this number with only one whole number before our decimal, so 4.16. And then we're going to write that as 10 times 10, and we moved it 1, 2, 3, 4, 5 places. So we're going to make that be the negative fifth, because that really means divide back that many places. All right, so times 10 to the negative fifth. So if you started out with a decimal number, you're going to have a negative right here. If you start out with a whole number, then you'll have a positive. All right, let's see if there's another one that I can do. Okay, so let's say that they give you a number written in scientific notation, and then you have to turn it into a regular number. 4.165 times 10 to the negative 7. All right, so I'm going to write this 4.165, and the negative 7 means I'm going to have to go backwards. I'm going to end up with a lot of zeros before my decimal there. So 1, 2, 3, 4, 5, 6, 7. And my decimal goes there. So I moved 1, 2, 3, 4, 5, 6, 7 places. So you take the decimal out, and that is the number that is represented by that. Pretty easy. You're just moving your decimal around. Remember, if there's a negative, it's going to be a decimal number, and if it is positive, you're going to go in the opposite. You're going to go move your decimal to the right. You're multiplying. If it's a negative, you're dividing. You move your decimal to the left. Okay, let me see if there's another example. This one is 714,600,000. Okay, so on this one, first thing I'm going to do is I'm going to write 7.146. I don't write any of those zeros. Then I'm going to figure out how many I moved it. 1, 2, 3, 4, 5, 6, 7, 8. I moved it 8 places. Times 10 to the 8th. It's really easy as pie. And you guys have probably done this before. I know that this is taught all the way back in like the 7th grade, 6th grade book of Saxon. So you guys should be pretty familiar with this. All right, so it says, this one says, here's a number, and they want us to write it in scientific notation. So I'm going to look for my actual numerals, and I'm going to write 1, and then my decimal point, so 3.16, and then I'm going to figure out how many I moved it. If my new decimal point goes there, I moved it 1, 2, 3, 4 places. It's 10 to the negative 4. Okay, to the negative 4. All right, that's not that hard. So go ahead and do those practice problems, and pause the video, do the practice problems, and then I'll work them for you. Alright, so hopefully you guys paused the video and did the practice problems. Here is A, 49,900. I'm going to write that with one decimal, one whole number, then my decimal point. 4.99 times 10 to the, let's see, I moved it 1, 2, 3, 4 places, times 10 to the 4th. Okay. B, 49,900 times 10 to the negative 11. Okay, so on this one, they want us to write this in scientific notation, but they already have it times 10 to the something. All All right, so the first thing I'm going to do is I'm going to work out what this number is. So to the negative 11 means I got to move my decimal back 11 spaces. So I'm going to write 4, 9, 9, 0, 0. And then I'm going to move backwards 11 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, now I'm going to write my number 4.99 because obviously that's what we need. Those are our only actual numerals, and our decimal needs to go there. Times 10, and so our decimal's really there. And then we're going to figure out how many spaces we have to go from this decimal to this spot. 1, 2, 3, 4, 5, 6, 7. So times 10 to the negative 7. 4.99 times 10 to the negative 7. Okay, that one's a little confusing. I'm going to show you another way to do that. Okay, we need to have 4.99. We already have the negative 11, but we're going to knock off 1, 2, 3, 4. What's 11 minus 4? 11, take 4 away, would be 7. Okay, so that was still that same problem. That was B. All right, C is 0.000499 times 10 to the third. Okay, 10 to the third means we have to add 3 zeros to this. So I'm going to do that first. And then 3 zeros. No, that means we have to move this decimal 3. 1, 2, 3. That gets us there. All right, so now we have to turn that into scientific notation, which would be 4.99. And how far did I go from here to here? Just one spot. So that would be times 10 to the negative 1. So 4.99 times 10 to the negative 1. Another way to do that is if we're at the 3 and we got to move 1, 2, 3, 4 places, 3 minus 4 is negative 1. Okay? All right, homework for this week is going to be lesson 74. And you guys need to try to get that done over the weekend. I have ordered a webcam, and it should be here shortly. And I'm going to try to do a group class where we can all see each other on like Zoom or something like that. I'm going to try anyway. So try to get your homework done so that we can have class together. And our next lesson will be 75. Ooh, slope-intercept method of graphing. That's a fun one. Alright, so lesson 74 for homework. If you have any problems, just send me a message. If you can't work out one of the problems, just send me a message. And I will make a video showing you how to do it. Ready?